My name is Omar Al-Azzam. I am a professor at St. Cloud State University. I will be presenting one of the papers that one of my graduate students actually worked on. I'm presenting two papers today for two graduate students working with me. They couldn't make it today because of time differences. So the topic that the first topic that we took on is artificial intelligence applied to software testing. So nowadays, with the emergence of AI everywhere, you see it everywhere. Everyone is talking about ChatGPT. Lots of concerns, and especially in academia, about the applications of AI. So the one topic that we thought we might be very interesting is how artificial intelligence can help us for software quality assurance, specifically how AI can aid in software testing. So, I mean, the software testing is a major activity in every software engineering life cycle. We need to make sure that the software is good enough performing in accordance to its the requirements and perform the tasks correctly as well. So we want to make sure that we identify defects and bugs as soon as possible, and those that the ones that cost us more if it propagate later on in the software life cycle. So the earlier that we can identify and fix these bugs, the cheaper it will cost us. But we all know that exhaustive testing is simply not possible because of the complexity of the systems. We still need to do comprehensive testing, but technically we cannot test for everything. And especially for those software that nowadays everyone is shifted to agile development, where we have multiple integration points, and then everybody's using cloud-based platforms that can keep track of our requirements, and then our integration of small pieces of working products. So we need to deploy multiple times. We need to test multiple times. We need to do continuous testings. So what we thought is, again, since AI nowadays, actually there are some platforms that can do testing using AI. We thought to test the benefits and then how AI can aid us in specifically three main categories: how we can make use of AI for test coverage, making sure that we have a good coverage in the code, how AI can help us reducing testing time while ensuring that we have good coverage, and then increase efficiency. So basically, it's not automation, but how AI can help us and to automate the testing process, the whole thing. So what motivated us, again, because of the growing complexity of the software, especially nowadays. I mean, it's not unusual to write software that include multi-million lines of code, especially in the gaming applications. So again, things like where we need continuous integration, we need integrate architecture, we need quick deployment and delivery of work on product, and where we're manual testing simply will give us a whole bunch of problems to cover lots of scenarios. Also, the need for utilizing time, so faster development and deployment, where we know manual testing will become time-consuming, resource-consuming, and then potentially pushing back the deadlines for the releases. Even if using Scrum, like your sprints might be delayed. And finally, focusing on efficiency and effectiveness. So again, how to utilize the computation power of AI and allow the system to learn the data and then optimize the testing process. Again, why we chose AI? Again, everyone is talking about AI, so the application is unlimited for AI. We use machine learning to generate test cases, predict what kind of defects we have, identify of areas in the software that will most likely have issues. Speaking of that, we know the 80-20% rule, where so we know, for example, 80% of the defects will come most likely from the same 20% of the code. So the trick is to identify the 20% faulty areas of code so that we can focus on those. And then using these machine learning techniques, we can improve test coverage as well. You can use also natural language processing to extract valuable information specifically from the software requirement specification. So the requirements, if done right, will contain lots of information that will help us to automatically generate test cases. So looking at documentation like software requirement specification document, test manuals, user manuals, any technical specifications, we can actually pull lots of valuable information to help us generate these test cases. There are also open sources that can use computer vision. So these can pull or generate test cases based on graphical user interfaces of software applications. So analyzing images of the application, screenshots, any GUIs that you have, we can test for user experience. We know, again, user experience, there is lots of effort done in this area because of the criticality of the task. We know users tend to like or dislike software based on simply how it looks like. And finally, better utilizing efficiency and effectiveness. How to reduce time, optimize test cases, and basically reduce the manual intervention of testing. There are some literature on the topic. If you're interested, you can look at the references in the paper. There are a few of them in the full text. But some of the papers focus on improving accuracy or focus on the limitations and challenges of AI testing AI-based system testing nowadays. So the whole area is new. I mean, AI, the whole area is new. We're still learning on the area, but the application is unlimited. So what we have done in this research paper, we've selected 2 software systems, and then we applied the three test approaches: manual testing, random testing, and then AI-based testing. And then we based our results on those. I have to mention that this paper will serve as a proof of concept. We know if we want to generalize, we need a larger data set to apply on. But I thought it would be interesting to show the results even on 2 software systems. So I would say that still more research is needed on this area, bigger data sets, and then we were limited based on time and manpower to do that because we need manual testing. So that's why we thought to begin with just 2 systems. For AI-based testing, we use machine learning algorithms to generate these test cases, and then predict where the defects will be, and then we compared with the actual defects and calculated the coverage and time based on that. And then we did a comparison between all 3 types of testing. Again, the type of comparisons we've done, we compared 3 different things. We compared coverage, so test coverage, where we found actually AI will predict a more accurate test coverage for you based on the generated. And I will show you the result in this diagram. It will be more clear. So this is again based on the two applications, and we found out AI-based testing will produce actually 95% test coverage versus 75 or 50 on both manual and testing. So significant improvement using AI for test coverage. For defect detection, so again, we know what kind of defects in these 2 systems, so these are predetermined. And then for AI-based testing, we detected 20 of them, where in manual testing, again, 15, and then random testing is 10. So the one thing I want to say about manual testing, this is based on one person trying to look for defects on limited amount of time. But still, again, using AI system, we were able to detect more bugs. For effort and time, we also found out AI-based testing actually, which makes sense, it will reduce the amount of time needed to generate the test cases and complete the testing. So based on the 2 systems, we needed 8 hours for AI versus 40. So again, we limited the number of hours to the number of hours for manual testing is 40. We thought 1 week full-time job will be enough test 2 systems. But again, we predetermined that, and versus 16 hours for random testing. So if you can see here, 40 hours, our developer detected actually 15 bugs. versus 8 hours detected 20 bugs in the two systems. So again, this will open the door of AI-based testing, we thought, to improve both efficiency and accuracy while ensuring more test coverage at the same time. In reality, you need a lot of data and technological experience to do AI-based testing. The problem of AI-based system to do testing, you need to train it sufficiently. So we know these systems, it need time to train so that it can learn from past experiences. So again, this is just the beginning using two systems. We think more research is needed in this area. But we see the benefits of using AI-based systems to detect defects. While also there are some drawbacks, but in general, for the small amount of data that we have, and we have the techniques that we applied, we showed that coverage can be improved, decrease the time needed for testing, and then while reducing effort as well. But still, more research needs to be done on this area. Again, the focus was on three categories: enhancing efficiency, accuracy, and then ensuring a good test coverage, as well as detecting as many bugs as possible. And then we've shown how AI-based testing can increase software quality in general, overcoming the manual testing drawbacks. That will be it for me. Thank you very much for